All right, so we are going to start talking about similarity. So we're going to start off with similar polygons, okay, and similar polygons. So the definitions to know, first off, this word ratio, hopefully you've heard that before. It's when you're comparing two numbers using division. It's fractions. Fractions are ratios. Fractions are division that has not been done yet. One that you're probably hopefully very comfortable with is slope, right? Rise over run. 3 different ways you're going to see ratios is where they use a colon in between it. They can use the word 2, or they can write it as a fraction 2 over 3. And it might actually look 2 over 3 vertically as well. Okay? So that's how we're going to see them most of the time for this class. We're going to see them as fractions. Okay, so a proportion is an equation. That means it has to have an equal sign with it. Okay, so proportions are equations, and they're stating that two ratios are equal to each other. This is what you just did on the previous page. Those were all proportions where you cross multiplied. Okay, and then when figures are similar, that's where that top part of the congruency symbol comes from. It means similar, that little whoop, okay. And when figures are similar, they have the same shape, but not necessarily the same size. So one is like a blown up version or a shrunken down version of the other one, okay? So very similar to the transformation stuff we were looking at, except the size of those shapes change, okay? So if you've heard of dilation, that would be what we're looking at here. So similarity ratios are what these guys here would be. Your fractions are your ratios that show you how big or how small one is compared to the other one. You're also going to hear the term scale factor. These two things mean the exact same thing, okay? And the big thing here is to make sure that we simplify our fractions, and I will go over those calculator steps again as well. All right, so here's a problem that you might see. The following polygons are similar. State the similarity ratio, then use it to solve for x, okay? So this is where you're going to bust out those colored pencils, okay? And we're looking for which sides correspond to each other. They match up with each other. So this 25 is on the right side of my figure, and this 15 is on the right side of my figure, so they correspond to each other. Then this x corresponds with this 24. So if you want to bust out some different colored pencils or highlighters, this would be the place to do so. When I want to figure out what my similarity ratio is, I have to use the one that has numbers because x doesn't help me with that. So I can look at either 25 compared to 15, or I can do 15 compared with 25. You just have to keep it consistent, okay? So if you want to simplify this in your calculator, 15 over 25 will be easier. You can type in 15 divided by 25 and get a fraction, or get a decimal, and then you're going to hit that second PRB button, and it will turn it into a fraction. Or, since you know you want to simplify, you can type in 15 and then hit that button that has the ABC fraction on it, and then hit the 25 and the equal sign. And on the screen, it's going to show you 15 with a little and then a little 25. And when you hit equals, it should simplify it down to 3 to 5. So make sure that you try that first before you move on. So if you need to pause this video and go get a calculator, please do so. So this turns out to be 3/5. When you do 25 over 15 and you do this process here, it's going to give you a mixed fraction first. It's going to look weird. It's going to have a number and then a weird fraction like this. When it does that, you just have to hit the second button and then that ABC button again, and then it will turn it into a improper fraction, and it should give you 5 out of 3. So before you do anything else, I want you to pause the video. If you haven't done so already, go get a calculator, try these calculator steps, and if you need to ask a friend, please ask a friend, okay? So what matters here is keeping in mind where the big shape versus the little shape is, okay? It's all about lining things up properly. So I have a tendency, and Miss Reisman has a tendency, to always go from left to right. So I always do the shape on the left to the shape on the right. You can always do small shape to big shape if you want to, but you need to find something that's consistent. So if I'm going from the shape on the left to the right, that means I'm doing the big figure over the small figure, okay? So for this guy, I have 5 over 3, big shape to little shape, and it's going to be equal to x over 24, okay? If you make this the 24 on top and the x on the bottom, you're going to get the incorrect answer. So you got to be really, really careful with that. And what's cool about this is you don't have to use the simplified version. You can use this version if it's easier for you. If it asks you for the similarity ratio, I like using it because smaller numbers tend to be a little bit easier to work with. So here we're just going to do a little cross multiplying. So we've got 3x equals 5 times 24. Okay. All right, so 3x equals 5 times 24 should give you 120. And then we can divide both sides by 3, and x will equal 40. And since this is a length, it's 40 units. Okay, so this guy right here, the length of this guy is 40 units. Okay, so there's 2 more example problems on the back of this that we'll walk through. All right, if we go to the back of this page, we're going to match things up again. So 14 is on the left side, 21 is on the left side, x is on the right side, 24 is on the right side, and then you've got an 8 here and you have nothing here. And since I already have my variable of x, this is not helpful to me. So I can just completely ignore it. I only need 4 elements anyways to set up that proportion, right? You only have 4 spots, so you don't need any more than that anyways, okay? So similarity ratio wise, I have to use the purple ones because they're both numbers. X over 24 doesn't help me, okay? So I have, and I'm going to go from my left to my right like I always do. So I'm going to do 14 over 21. So I'm typing in 14. I'm hitting that ABC button, and I'm typing 21, and that should reduce down to 2/3. That is my similarity ratio or my scale factor. And then I'm going to take that 2/3 and I'm going to set it equal to, and I have to go from the left to the right. So I have from my x to my 24. And if it helps, right, my left side is my smaller figure and my right side is my larger figure. So small to large for this one, okay? And then same deal, we're going to do a little cross multiplying. So I have 3x equals 2 times 24. 2 times 24 gives me 48. And then I just need to divide by 3 to get that x equals 16. And again, this is a length, x by itself, so this is units. Okay. Let's look at this last example. So in this one, I have 3 things that match up. I have 20 with 24. I have 40 with 5x plus 3. And I have 35 with 42. I don't need all of those, so I can pick which ones to use. But I have to use, in this case, the purple ones because that has the x involved. Okay, so I know I'm definitely going to use 40 over 5x plus 3. I have to use that one. And then I get to pick which other one I'm going to use, orange or black. And since the orange letters are smaller, I just like using smaller numbers because that makes it easier to me. So 20 over 24, if I reduce that in my calculator with that ABC button, I should get 5 over 6. And this is my small figure to my large figure. So the numbers on the top should have something in common. These two and these two should have something in common, okay? And you know what? Let's do this one. We're okay. So if I do a little cross multiplying here, I'm going to scoot this up so I have space. I'm going to do 5 times all this, and I have to put those in parentheses. It is 5 times that entire expression, which means I'm going to have to distribute. And then I have 6 times 40. So 5 times 5 gives me 25x. 5 times 3 gives me 15. 6 times 40 gives me 240. And then I can subtract 15 from both sides. That knocks out. 25x comes down, equals stays in the same place, and I get 225. I can divide both of those by 25. Knocks that out, and x equals 9. Now in this case, that 9 is not 9 units because this side here is not just x, it's 5x plus 3. So to figure out what that side would be, what that unit would be, we just found out that x is 9. So we're going to use that to our advantage up there. We are going to do 5 times that 9 plus 3, just like we've been doing with a bunch of stuff, right? 5 times 9 gives me 45 plus 3, so this is 48 units. That would be this length of the triangle right here. Okay? So you've got some homework problems to look at. So some of them just have numbers, and they will be more like example 1 and example 2, and then some of them have expressions, so they'll be more like example 3. So just make sure you're using your notes to help you, make sure you're matching things up, and there is an answer key for you, so you can check if the answers are correct.